Hey, it's Mrs. Matt here, and I wanted to take a minute to go over this review assignment since it's your last review before your final quiz at the end of this week. So we have our first problems here to write these two expressions in standard form. And so remember, to get to standard form, that means to multiply those out and combine the like terms. So a lot of you have been using the box to multiply these expressions by each other, which is great. And so down the side of the box for x plus 4 times x minus 1, I'll do the x plus 4 on the side and x minus 1 across the top. And then inside the box, we're just going to be putting the answers when we multiply. So for the first box, x times x is x squared. And then 4 times x is 4x. That's a 4. X times negative 1 is negative 1x. And 4 times negative 1 is negative 4. Okay, so then we'll put it all together in one expression, and it will look like this. So from the first box, x squared, and then minus 1x plus 4x, and minus 4. And then finally, the minus 1x and plus 4x in the middle, those can be put together. They make 3x, so plus 3x all together. Okay, so in the box, I'm going to type my response, x squared plus 3x minus 4. And notice it says I'm correct. So the second problem here is very similar. You're going to follow the same process. Build a box. You can use the second sketch pad here. And it's 2x minus 1 down one side and 3x minus 1 down the other, or across the top. And I'm not going to finish this problem. Just wanted to show you how to set it up in case you're stuck. Then you can go ahead and multiply, list the terms, add the ones together that you can, and type your answer in the box. It's also self-correcting, so as long as you did it correctly, you'll get the message there that it's correct. All right, so the next question, is this expression in standard form? And then is it equivalent to x minus 4 times x minus 2? So it is in standard form. We just normally see standard form starting with x squared and then minus 6x. It's just a little bit out of order. And then since the 8 is positive, plus 8. Okay, so it is in standard form. It's just not in the order we normally see. So you can click on yes. And then is it equivalent to x minus 4 times x minus 2? Again, you're going to figure out whether it's equivalent by multiplying out x minus 4 times x minus 2. And once you multiply it out and put together the like terms, if it gets the x squared minus 6x plus 8, then you're going to say, yes, they're equivalent. Or if it gets something different, then you're going to say no. Okay, so you can finish that up. On slide 4, which quadratic is written in standard form? So the first and second one, they have some multiplying parentheses, not standard form. Same with the last one, just the third one down. Negative x squared minus 5x plus 7 is in standard form. It's all been multiplied out. There's no parentheses. So that's it. Okay, then we want to talk about an equation that's in factored form, x minus 7 times x plus 3. To first identify the x-intercepts. And just remember, the x-intercepts are the value of x that makes that factor equal 0. So for x minus 7, when x is 7, it's going to equal 0. So that's one of the x-intercepts. And then for x plus 3, when x is negative 3, then that will equal 0. So that's the other x-intercept, all right? And then for the last part, when it says to expand, it means multiply it out, write it in standard form. So x minus 7, oopsies, that's not very good, 7 times x plus 3. So 3 goes here. So when we multiply this out, we get x squared, 3x, negative 7x, and negative 21. Oopsies. Okay, so the whole thing is going to be x squared. Negative 7x plus 3x makes negative 4x, so minus 4x. So that's from those two, adding them together. And then minus 21 is our constant. So since the constant is minus 21, if we replace the x's with zeros, we would get 0 squared minus 4 times 0 minus 21, which equals negative 21. So that's why negative 21 is going to be the y-intercept. We're going to write it as an ordered pair. When x is 0, y is negative 21. Okay, slide 6. In order to determine which expression could define this function, I need to know the x-intercepts. There's one at negative 1, and there's one at positive 3. So this x-intercept here at negative 1 tells me, because that's negative 1, that one of the factors is x plus 1. Remember, opposite sign. And then the other one here at positive 3 tells me the other factor is x minus 3. Remember, again, opposite sign. So that tells me the one that matches it up is x minus 3, this one here, x minus 3 times x plus 1. Okay. And moving along. So the x-intercepts, factored form. Okay, if we're looking for the x-intercepts, we want to look at factored form. But then the y-intercept, that's where we multiplied it out and put it into standard form. So that's how you can tell there on slide 7. Almost done. Okay, which graphs open upwards? We're looking for positive on the x's. This one's a little bit tricky. I'm going to go from the bottom to the top. The bottom, it has to be a negative out here in the front to make it go down. So that one's going up. Above it, this is where this one's a little bit tricky. This one's actually going down. Don't spend too much time worrying about this. It's because one of the x's is minus and the other one is plus. So it will have a negative x squared once it's multiplied out. So it'll go down. The next one up, positive in the front. And then this has a see that minus in front of the 5x squared and the minus in front of the x squared. So if these equations were all in order, the x squared is what comes first, and that's where it needs to be positive to go up, negative to go down. Okay, we have a graph here. This graph has, see that? One of the zeros is when x is -7, so an x-intercept at -7. The other one is at 0. So to write an equation for this graph, I want to think about the x-intercept. So this one here at -7, this one here at 0. So again, opposite signs. So I could say x plus 7 for the x-intercept at -7. And then for the x-intercept at 0, I could say x plus 0. But normally we just say x. So I would write the equation like this. Typically, x would come first and then x plus 7. But you could have the x at the end as well. But this is what how we typically would write this. Okay. And we're just about finished. Slide 10. In vertex form. So I think it's probably really obvious the top one and the bottom one are in vertex form. What you might not know is this one here is as well. It's just that the x value in the vertex is 0. The next one's in factored form. And then the next one down is actually in factored form, but it's also in vertex form because it has like, plus 0 at the end. So the vertex is going to be -3, 0. So 2 of those were obvious and 2 of them were tricky. Okay, what's the equation represented by this graph? So here's what I know about the equation. Since it's opening down, it's going to start with y equals negative. Now, in vertex form, our x value is -3, so that tells me x plus 3 in the parentheses because the opposite sign for the x value. Now squared. Then since the y value in the vertex is negative, it's going to be negative in the equation, -1. And that's the answer. So it looks like it's this answer choice right there. And finally, the last slide. What is the vertex? Well, the vertex is, let's see here, x -3 tells me +3 for x, and then +6 for y. Identify the y-intercept. So the y-intercept is when x is equal to 0. So I'm going to write my workout here in the sketch pad. -0 -3 squared +6. Oh, that's a 6. And I might open the calculator to have it get the answer for me. And my video was in the way. Okay. It's not flashing yet, but let's see what happens. Okay. -0 -3. Oh, here we go. It's just taking a little bit of time. Squared, and then +6. And the answer is coming, it's thinking -3. So when x is 0, y is -3. So the x-intercept when x is 0, y is -3. And then it says identify one additional point on the graph. Well, guess what? I can change this 0 to any number I want. I already have it for 0, for 3 when x is 3. How about 5? When x is 5, the answer is 2. So I changed it to a 5. It's the beauty of using Desmos. There's another point on the graph, okay? So there's lots of other points you could find as well, just by plugging in different numbers for x and finding the answer for y. Okay, well, that is the end of your review. And so if you've got questions, we will cover questions at the beginning of class before you take your quiz. Otherwise, I'll see you in class after I figure out how to stop the video. Oh, there it is.